And I'm live. That is very nice. Today is 15th of October 2025, Wednesday, and 15th of October is a very nice day. Why? Because yeah, this guy. There was this guy who was born on 15th of October 1844 at this place, Rochen, Deutschland, and died in 1900, 25th of August 1900. Weimar Republic. Weimar is something. And with that, let's begin the stream. We are going to be building our own database, Redis from scratch. This is just joy, pure joy introduction. We will be building our own Redis with C/C++ from, yeah, from scratch. That is just amazing. And let's simply begin. Build real world software by coding from scratch. If you can build a Redis server, you can build almost any software beyond CRUD because it teaches you three fundamental skills. Network programming. The next level of programming is programming for multiple machines. Think HTTP servers, RPCs, remote procedure calls, databases, distributed systems. Distributed systems. This term I do not understand completely, but after this, at the end of this, like we will be very good with these terms. So we will be doing network programming, and with this, the kind of goal is first of all to just learn and also learn and grow. Data structures. We are going to be reading about data structures. Our data structure skills will become strong. Redis is the best example of applying data structures to real world problems. Why stop at theoretical textbook level knowledge when you can learn from production software? Yes. Low level C. Yes. Low level C. Low level. Anything that is low level is amazing. C was, is, and will be widely used for systems programming and infrastructure software. It is a gateway to many low-level projects. I guess Rust is also in the picture now. Why from scratch? A quote from Richard Feynman. Shit. What I cannot create, I do not understand. And this is pretty cool. What I cannot create, I do not understand. You should test your learning with real-world projects. This is pretty cool. What I cannot create, I do not understand. This is what he said. What I cannot create, I do not understand. That is nice. That is a nice thing to say. Why a book? The real Redis project is a large code base, a large, like Alex DeLarge code base built with lots of effort. The book distills the core concepts and guides you through small steps. Okay, it distills the core concepts and guides us through small steps. And now introduction. Okay, this is into two parts. Redis from 0 to 1, like from nothing to something working. And then we have advanced topics, which has thread pool at the end of it. Okay, well, of course, first we will be going through this. It has socket programming, TCP, server client, request response protocol, concurrent IO models, event loop, part 1, part 2, key value servers. Okay, this is just joy. Introduction is quite small. That is very nice. Okay, with this, learn how to build real world software by coding a Redis server from scratch. If you can build a Redis server, you can build almost any software because it teaches you two fundamental skills: network programming and data structure, which we just read about here. Now, what is Redis? That is a nice question. Redis is the most popular in-memory key value store. In-memory key value store in memory. That is, it is in the RAM, not on the hard drive disk. And key value. This is the key. Give me the value. Key value. Okay. Used primarily for caching as no storage is faster than memory except caching as no storage is faster than memory. Caching servers are inevitable because it is the easiest way to scale. A cache can take slow database queries out of the equation. Okay, makes sense. A cache server is a map string to string. This is C++, pure C++, map string to string over a network built in Redis. The value part is not just a string. It can be any of the data structures, hash, list, or sorted set, enabling complex use cases such as ranking, list pagination. Okay, ranking. I've heard these terms before. Ranking, pagination. Pagination is like you divide the whole memory space into different pages, and you say whenever you are fetching something, you say from this page I want something with this offset, kind of like that. But yeah, these things will become clear with time. This is why Redis is called a data structure server. Okay, so what is this? This is saying Redis is a in-memory key value store. That makes sense. In memory, it is like in the RAM. Let's build some shit. Our definition of Redis with red. And okay, so what are the things that Redis has? It is, first of all, okay, how, first of all, in memory, like in RAM. That is okay. Okay, it is in memory, so it is fast, faster than the disk. Okay, this makes sense. Redis is like fast because it is in memory, and it is faster than the disk because it is in memory. Okay, okay, this much makes sense, and it is key value. Key value. Key. It is the data in Redis is stored in the format of key value pairs. So, okay, key value format. Okay, now I have a doubt that is it like literally stored in a key value pair, or is it is it stored in key value pair, or is this how the data is supposed to be interpreted? And under the hood, it is stored in some, it is actually stored in some other format, and we will get to know when we are literally building our own Redis. Okay, used primarily for caching as no storage is faster than memory. Yeah, okay, we can go with that. Caching servers are inevitable because it is the easiest way to scale. Easiest way to scale because if you do not cache, if you do not have caching servers, then when you scale, your main servers would get overwhelmed because there will be a lot of requests, and they are slow by design, by definition, because normal servers store things, normal databases store things on the disk, and fetching from the disk and then sending back is slow. So it is better to use a Redis, which is in memory, because first of all, I guess it is cheaper. Cheaper? I don't think it would be cheaper because RAM is not cheap than the disk. Disk is more cheaper than RAM. But I guess the advantage is, first of all, it is faster. So in a given amount of time, Redis can handle more requests than a normal typical DB. Therefore, a better user experience. Okay, a cache can take slow DB queries out of the equation. Yes, we can agree with that. A cache server is a map string by string over a network key value. But in Redis, the value part just is not just okay. Is Redis like a literal company, or it is supposed to be a general concept which has been implemented by a company called also named Redis? It can be any of the data structures, hash, list, or sorted set, enabling complex use cases such as ranking, paging. That is why, okay, enabling complex use cases such as ranking and page list pagination. I guess we don't have to delve completely into this because we will be building it in due time. But this is why Redis is called a data structure server. First of all, because it is a server, therefore server, and data structure server because it is using literally this data structure of a map key value data structure. I guess that is why it is called a data structure server. And now for the other question, uh, a cache server is a general concept which is uh, used to describe servers which have been set up to ease the load on the main DB servers and also increase the response of the application. And is Redis one of the examples of such a cache server? Now, yes, we do know that cache server are a general concept, not that we do know, but that is what we have interpreted. But is what is Redis then? Is it just a company or a class of cache servers in themselves? Redis is one of the most common examples of a cache server. Let's unpack that step by step. What a cache server really is. A cache server is a system designed to store frequently accessed data in memory RAM so that applications can retrieve it faster. Okay. Redis is a cache server. Redis, remote directory server. Shit, that makes sense. Remote directory because it is key value paired. Key value paired. That is why directory and it is a server is a perfect example of this concept because it stores data in memory RAM. It supports key value pair and it has automatic expiration TTL as in okay TTL. So cached data can expire and stay fresh. Makes sense. It is designed for high concurrency and low latency, ideal for caching, real-time analytics, sub, etc. How it fits in the architecture. Uh, okay, here is the client making a request to the application server, and now the application server goes to Redis, and if Redis doesn't have Redis, which is acting as the cache server, if it doesn't have the data, then Redis goes to the database server. Otherwise, if Redis does have the data which is required, Redis responds to the application server, which gets back to the client. Okay, there are other cache server CDNs. Yes, CDNs are also cache servers. Varnish, Varnish cache server. Wait, so Varnish and CDNs, these seem to to be a model of things. Hello. Look, can you tell which websites you refer to CP and projects? Yep. For theory, there is course, our book, Competitive Programmer's Handbook for theory. Everything is here. And if you want to like go deeper, then there is this thing, Introduction to Algorithms. You can delve into this. And if you want YouTube videos, there is, of course, my streams. No, they are bad. Do not watch them. But there is this guy, Ericto. You can watch his streams and his videos on topics, algorithm lectures, and he also has a series playlist here. This thing, it is just named Edu. It is just called Edu, edu, just Edu, nothing else, just Edu. And yeah, this is binary search, dynamic programming, 3 lectures on dynamic programming, and then a randomized algorithm, some streams, bitwise operation, bitset, and yeah, how to start competitive programming. This is also one thing. Modulus operation, binary exponentiation, matrix exponentiation. This I don't know. That's Fibonacci in log n, Chinese remainder theorem. This is cool. Binary lifting, Keith neighbor, lowest common ancestor, sparse tables, and range minimum queries. This is cool. This is cool. I think he also has something on segment trees. Hmm. Where is his segment trees? He has sparse table. Where is segment trees? I think he did a stream on segment trees. Yeah, he did a stream on segment trees. And also one video, IOI preparation. Yeah, you can watch these. These are the things you can watch. Mr. Ericto, 2018 finalist, Code Jam, printf finalist. Print, not printf. Okay. With that is Redis a general concept for a cache server or a company which has implemented its own way for caching. Redis is not a general concept, it is a specific implementation, a real concrete software system that embodies the concept of cache server, among other things. Let's clarify the layers here. The general concept, cache server. Redis is a specific implementation. Redis is a specific piece of software. Okay, like GitHub. Git is an example of version control. Makes sense. Okay. Okay. We can move forward with that. From that, yep. Why start from scratch? That is a nice one to code. Richard Feynman, what I cannot create, I do not understand. There are different levels of create and understand. Gluing libraries together is create. Makes sense. Attaching npm install this, npm install that. That is creating. Look at this. I created a website. Okay. But you don't have to stay at that level. You can create something more low level and understand something more fundamental. Mhm. The goal is not to reinvent the wheel, but the fundamentals will set you apart. You will make better decisions, be better at debugging, and who have more career options. Yes, we want money. Yes, that is why we are doing everything. Why C or C++? The first level of Redis was written in the TCL scripting language. Shit, I don't know what TCL is. TLS is. TCS is something. This is cool. Okay, TLS is scripting language, but that is only a toy version of Redis. The final product is in C++. Creating a toy version of something is a great way to understand it, but there is always more to learn. Okay, why C and C++? High performance software requires low level control, which requires C and C++. I think this article is old because this is just not acknowledging the fact that Rust exists. C doesn't have built-in data structures or networking, so it forces you to learn. Yes, yes, that is amazing. That is amazing. The code is plain C with minimal options, optional C++ features. Okay, okay. It should be readable without C++ experience. I hope this will motivate you to learn C++. We know a bit of C and C++, but other languages can be valid for subset of the lessons. Go is more high level, but it is still good for coding data structures and manipulating bits and bytes. It has a mature built-in networking library, so you won't learn the full networking lessons. We do want to learn the full networking lessons. It will make us apart. Python is too high level for coding data structures like hash tables because it is built in. Production stuff is mostly C with Python glue. Python only has a thin wrapper for socket, so the networking lessons are still suitable. Okay. JavaScript is as high level as Python, but with an invisible event loop and built-in networking. To fully understand JavaScript or Go, you need to know more than JS or Go. Ah, why should I code a Redis? That makes sense. It prepares you for more technical systemy works and gives you new career options as generic software development is de-evaluated by AI tools. Okay, it is a good practice, especially if you are a student without real projects. Yes, we will be building our own projects, so that is nice. It is quick review. It is a quick review of the basics, which is helpful for job interviews. Okay, yes, it is fun. Fun, yes, it is fun and intellectually stimulating to know how things work. Yes, and we will be able to know how networking programs work and what data structures are. Data structures. About the book, each chapter is an incremental step with the complete source code, which you can just read. The final product is only 1,200 lines of code focusing on principles while skipping uninteresting details. It is not a mindless Redis clone. Many things are done differently to be better illustrated, to better illustrate the topics, so the result is not compatible with the real Redis. Is not compatible with the real Redis. Get help from the author here. Okay. Okay, we can go to the next thing, which is yo. We are already at socket programming, which is just joy. Prerequisites, basic networking knowledge. I think we have that and want to learn from black boxes to code. Yes, we will be converting our black box, the internet, into code. That is nice. Computer programs are often simplified as boxes connected by lines. Computer networks are often simplified as boxes connected by lines. That is true by the actual coding, but the actual coding is left out. However, network programming is not trivial. Given an API with two methods, send data and receive data, what else do you need to know? Yes, yes. If we have an API which has, we just literally need two things. How do I send the data to the database and how do I get data from the database? The TCP byte stream and protocols. Okay, this is too good. And let's initialize the project in Tmux. And shit, let me update my Tmux script so that we have some extra sessions. Okay, yep, yep, ds neom. We can say this is for Redis and And this whole thing we can just change every time that C++ occurs with Redis. Substitute C++ with Redis. Uh-huh. And we will build. Do I have a project folder? Yes, shit, yes. Make dir Redis. Okay, we do have Redis now. Tmux. La Not languages. Uh, Projects Redis. Uh-huh. Cool. Projects Redis and tmux set. Tmux attach target is Redis, and we are in our Redis folder or directory where we will be doing everything. Okay, what do we have? We have TCP byte stream and protocols. Okay. TCP transfer control protocol, byte stream and protocols. People often visualize computer networks as peers exchanging messages, but the most common protocol TCP doesn't actually produce messages. It produces a continuous stream of bytes with no internal boundaries. Okay, I do get this continuous stream of bytes. One computer is sending continuous stream of bytes like 8 bits, bytes to some other computer with no internal boundaries is okay. I don't know what this means. With no internal boundaries. Interpreting this byte stream is the job of an protocol. Application protocol. Okay, let's also have in mind the ISO model. ISO or yes, interconnected software OSI model. Shit, OSI model. What is the full form of OSI, by the way? Open Systems Interconnection. So where are we? Okay, this is the thing. And copy image. Here we have this. Okay, we have a bunch of things here. Application layer. Okay, this is, yeah, this is like the browser. And then I think we don't have to think about these two layers. These are just extra things. And then we have transport layer, which actually runs TCP, I think. And then we have network layer. Let me, shit, it is gone. It is gone. It is gone. Copy image. Application layer, and we can just skip these two. I think I was watching a video, and in that video they were saying these two are just extra layers. Like, yeah, these two kind of act like buffer layers, which you don't actually have to get into. But yeah, with due time, after due time, but not right now. This is fine. So application layer and application layer, we have applications, like literal application, browser or something that uses the internet. Browser uses the internet, and what else uses the internet? Anything that uses the internet comes at this layer. Then we have the transport layer, sends uh, data from one computer to another. Yes, that is what the transport layer does. And then we have network layer. Network layer. Gerardo. The closest layer to the user provides application data, and presentation layer encrypts, encodes, and compresses usable data, and session layer establishes, manages, and terminates sessions between shit. Go back. And terminates sessions between end nodes. We can ignore those two things. Then transport layer transmits data using transmission protocols, including TCP and UDP. TCP is transmission control protocol and UDP is user datagram protocol. TCP relies or guarantees that your data will reach the destination, and UDP just sends the data from their side, from the source computer, and does not guarantee that the data will be reached, like the receiver will get the data. It is not guaranteed by UDP. Then we have network layer below that, assigns global addresses to interfaces and determines the best routes through different networks. It is like the literal web thing. And then data link assigns local addresses to interfaces, delivers information locally. MAC method, like send one data packet from one router to the next router, that is handled by the data link layer. And then we have the physical layer, encodes signals, cabling, and connectors, like literally your Wi-Fi, physical hardware, Wi-Fi or wires maybe, for sending data here and there. That is nice. That is what this is. And yep, people often visualize computer networks as peers exchanging messages, but the most common protocol, TCP, doesn't actually produce messages. It produces continuous streams of bytes with no internal boundaries. Interpreting this byte stream is the job of an application protocol. Rules for making sense of the byte stream including how to split it into messages. For making sense of the byte stream, including how to split it into messages. Application protocol, this makes sense. HTTP is one of the application protocols, and okay, application protocols are rules for making sense of the byte stream, which has been transferred using the TCP layer. Okay, for making sense of the byte stream, including how to split the byte stream into messages, and how to interpret those byte stream messages. Splitting a byte stream into messages is trickier than you might think, especially when within an event loop. It is not like parsing some file formats. Okay, data serialization. The message you want to send via a network can be high level objects like strings, structs, lists. However, computer networks only know zeros and ones. Thus, it is necessary to create a mapping between objects and bytes. This is called serialization. Objects, object to bytes, and deserialization, bytes to object. Okay, makes sense. This makes sense. The data that you want to send from one computer to the next one, the message could be a high level object, not just a like, yeah, it could be a high level object, and they are considering strings, structs, lists as high level objects. And but the computer network through which we are sending the data only knows zeros and ones. Thus, it is necessary to create a mapping between those objects which you want to send and their 0 1 representation, bytes. And this is called serialization, objects to bytes. And deserialization, which would happen at the receiving end, they would convert those zeros and ones back into objects, which themselves, like, they would also be handling those objects as zeros and ones internally, but the format of those zeros and ones could depend on their own implementation. But the thing is, yeah, the zeros and ones which they are using to communicate with each other, these objects, that has to be like kind of standardized. Okay, they have to be talking the same language basically. While you can do this trivially via JSON or protobuf libraries, rolling your own by manipulating bits and bytes is good to start to low-level programming. That is just nice, beautiful. Okay. Okay, so we have learned one thing, which is serialization, objects to bytes, and then deserialization, bytes back to objects on the receiving end. Mhm. And concurrent programming. It is, wait, where is like the actual code that we are going to write? Okay, we have it here. Okay, we are going to write some code later. Summary list, summary list of socket primitives. We will be using bind, listen, accept, close a socket, and how to use TCP socket. Read, write, close, create a TCP connection using connect. The next chapter will help you get started with real code. Yes, that is what we want, but we cannot just skip there. You have to go through this thing before. Shit. Okay, concurrent programming with, okay, what have we seen till now? Till now, we have seen data serialization, that is zero one representation of, over the network of that message that you want to send. Serialization, and we also have deserialization on the receiving end. Then the TCP byte stream. Okay, TCP sends data as byte streams, and the application protocol are rules which define how those byte streams should be interpreted. Okay, okay, makes sense. Concurrent programming. With a protocol specification, you can easily build the client application. You can easily build a client application, but the server side is more complicated because it deals with multiple connections. That makes sense. Dealing with many concurrent connections, even mostly idle, is historically difficult. The C10K problem. Okay, so okay, if we do have a protocol, it is very easy or relatively easy to build a client-side application. But to implement that same protocol on the server side, it is more complicated because a server has multiple connections that it has to juggle with and keep track of and do like give actual correct response to every single connection. Okay, dealing with many concurrent connections, even mostly idle, is historically difficult. The C10K problem. Okay, there is a C10K problem. Although 10K is a connections, 10,000 connections problem. Although 10K is a tiny number on modern hardware, efficient software is required to make full use of the hardware. Okay, okay, okay. They are saying when we have a protocol, it is very easy or relatively easy to apply it on the client side, but more complicated on the server side because server has to like keep up with multiple connections. Okay, the modern software solution is event-based concurrency with event loops, which drives modern scalable softwares like Nginx, Redis, Golang's runtime, etc. Event-based concurrency. Okay, they are now talking about event-based concurrency with event loops, which we will know in like the later chapters. So yeah, I guess we don't have to go too deep into what event loops are. We will be like implementing our own at in later chapters. That would be nice. Event-based concurrency may be a new programming paradigm for you. Mhm. It is really complicated, so you should learn it by doing it. Okay. Network from a programmer's perspective, layers of protocols. Okay, I think we can consider this whole thing quite done. TCP, then data serialization, then concurrent programming, and now onto this thing, layers of protocols. Abstract idea. Network protocols are divided into layers. Network protocols are, yes, divided into layers like the OSI model, open networks, open systems intercommunication. A lower layer can contain a higher layer as payload. A lower layer can contain the higher layer, a higher layer as a payload, and the higher layer adds new functions to what the lower layer provides. Okay, makes sense. Reality. Ethernet contains IP. Okay, IP happens on Ethernet. IP contains UDP or TCP. UDP or TCP contains application protocols. So this is like the literal hardware physical thing that we are using. Then over that physical thing, we are doing IP, Internet Protocol, Internet Protocol, or okay, it is Internet Protocol. Internet. We use IP to identify which is the target computer, and when we do know, have a method IP layer to identify which computer is which. Then we use UDP and TCP to send data, not to send data, but to make sure that we are sending data using these two things. And when we know how to send data, we make use of what we can send and how it is going to be interpreted. And that happens on the application layer, application protocols. That is nice. Alternatively, we can also divide the layers by function. We can also divide the layers by function. This layer of small discrete messages, IP, the layer of small discrete messages, IP layer, shit. It, here they are saying, this guy is saying that we can also divide this by, divide the layers by function. So how are they dividing the layers here? Okay. The layer of small discrete messages, IP. When you download a large file, the hardware cannot possibly store the whole data before forwarding. When you download a large file, the hardware cannot possibly store the whole data before forwarding. It can only handle small. The hardware cannot possibly store the whole data before forwarding. Like the place from where we are downloading, it can only handle small units, IP packets. That is why the lowest layer is packet based. The ability to assemble packets into application data is provided by a higher layer, usually TCP. So we like, I cannot just download a 2 GB movie. We break it down into small packets, and those packets are assembled on my computer, which have been sent to my computer from some other server from which I'm downloading some movie. And those packets are assembled together by a protocol, application protocol called TCP, usually Transport Control Protocol. Okay, the layer of multiplexing. Multiplexing is a nice word. Port number. Multiple apps can share this. Okay, yes, the same network on a single computer. How does the computer know which packet belongs to which computer? This is called demultiplexing. The layer, the next layer of IP, UDP or TCP, adds a 16-bit port number to distinguish different applications. Each app must claim an unused local port number before it can send or receive data. The computer uses the for tuple to identify a flow of information. Okay, This is a lot of information. So let's say my browser asks google.com for some data, and google.com sends back the data to my computer using my computer's IP address. Now, when the data is back to my computer, how does my computer know which application was asking for that data? It is identified by the port number of the application, the port number, and I think we should be able to see it. If we go to CPU, we don't see the port. Yeah, we don't see the port. Network, sent bytes, receives byte, PID. OBS is working like pretty high. Sent byte. It has sent 4 GB of data already and has not received a lot of things. 21,000 bytes packets have been sent. That is nice, kind of. And it is still sending a lot of data. Okay. And okay, so we distinguish which application the data goes to using the port number of the application. Makes sense. Source IP, source port. Destination IP, destination port. The computer uses for tuple to identify a flow of information. This thing, it has to know the source IP address, the source port, and destination IP and destination port. Okay, makes sense. The layer of reliable and ordered bytes, TCP. Small messages are usually not what you want. Small messages are usually not what you want. The file transfer use case requires arbitrarily, small messages are usually not what you want. Okay, the file transfer use case requires arbitrarily large data. Okay, worse, the network is unreliable. IP packets can be dropped, reordered. TCP provides a layer of reliable and ordered bytes on top of IP packets. It handles retransmission, reordering automatically. Okay, so now since we have a layer which can send data from one computer to the other computer, the IP layer, we need a reliable way to send data between two computers so that we make sure what I send is what it was received by the other computer in the same order and nothing was lost. That is handled by TCP, Transport Control Protocol. It is a higher level thing and IP is a lower level thing, and reliable, ordered, bytes, port, and ports are also handled by TCP, I guess. Ports in TCP and UDP multiplex to programs. Multiplexing is just saying using a single like Wi-Fi card to send and receive data for all the applications which are using that same hardware or which are running on the same computer. Then three layers represent three needs in networking. They are mapped nicely to TCP IP concepts. There are other models such as TCP IP model, where we have application layer, transport layer, then IP layer, then link layer below IP. Okay, the TCP IP model represents the protocol header structure. The protocol header structure which puts TCP and UDP on the same level, but TCP has a higher function while UDP is just IP plus port. Okay, so TCP is kind of like more complicated than UDP because UDP just sends and receives data and doesn't make sure that the data goes to the other side. But TCP does do that. TCP makes sure that when you send some data, it is received in the same order by the receiver. There is also the OSI model, but the model is more complicated than the reality TCP IP. It tries to model. So just ignore it. Okay, we'll ignore it. What is actually relevant to us? Yes, that is a good question. Typically, applications do not interact with the IP layer because multiplexing is a universal need. Makes sense. Okay, so whatever the application it is, it is going to use multiplexing using ports to send and receive data by the operating system by a single NIC, network interface chip. The only thing we care about from the IP layer is the source and destination address. From the IP layer, the only thing that we care about is the source and destination IP address. That makes sense. We are using the IP layer, which is used to send data between computers. And the only thing that we care about in that layer is the source from where we are sending the data and the destination where we are sending the data. Ethernet is below IP. IP uses Ethernet to send data from source to destination. It's also packet based, but uses a different type of address, MAC address. Media MAC addresses are used by the hardware that does not care about IP, such as some network switches. So uh, these are just facts which are coming out at our face. Ethernet is below IP. Okay, yes, that is acceptable. Yes, that makes sense. But it is also packet based, but uses a different type of address, MAC address. So IP uses IP address and Ethernet uses MAC address. MAC address full form. Media access control address. Media access control address, it is a unique identifier assigned to a NIC, network interface controller, by the manufacturer for use in local network communication. So when one computer is sending data to some other computer, they are using the MAC address of that target computer, I guess. Okay, okay. And this is used MAC address by like almost the physical layer. This Ethernet would be the physical layer, I guess. Okay, and MAC addresses are used by hardware that does not care about IP. That does not care about IP. They have their own way of uniquely identifying computers, which is called MAC instead of IP, which uses IP addresses, such as some network switches. Network switches use MAC addresses, and switch, switch is something switch is something to which different computers can connect to, like directly by plugging something in, and they will be those computers which are connected to a switch, to a common switch, they will be able to talk to each other when a source computer knows the MAC address of a target computer. So it can just tell the switch, this is the data, send this data to the network, to the computer which has this given MAC address. Okay, so network switches uses MAC address. We do not care about this layer. It may not even exist in VPNs, virtual private networks. The layer above IP are what we care about. Application uses TCP or UDP either directly or by rolling their own protocol, or indirectly by using an implementation of a well-known protocol. We will do the formal like the real Redis by creating our own protocol. Okay, both TCP and UDP are contained by IP. IP can contain other protocols like SCTP, but in 2025 only TCP and UDP matter. Everything is built on top of TCP or UDP. UDP is used for things like this, literally streaming, and TCP for reliable data sending something. Conclusion: IP, port, TCP, UDP are concepts we will deal with. Okay, and we do have a basic understanding of what these things mean. Okay, we are almost getting at the programming part. Now, this thing, request response protocols, Redis, HTTP 1.1, and most RPC remote procedure calls protocols are request response protocols. Each request message is paired with a response message. If the messages are not both reliable and ordered, there will be troubles pairing a response with a request, and that is handled by TCP. Thus, most request response protocols are based on TCP. DNS is an exception. Okay, so DNS is also a request response protocol, but it is not like built on top of TCP. Okay, okay, and Redis and most RPC protocols are request response based, for which we need a reliable ordered connection, which is provided by TCP. Packet versus stream. A packet is a singular thing, and a stream is a bunch of packets going one after the other. TCP provides a byte stream, but typical apps expect messages. Few apps use the byte stream without interpreting it. Thus, we either need to add a message layer to TCP or add reliable. It's been 56 minutes, and why am I already looking at the time? TCP provides a byte stream. Makes sense. Makes sense. TCP provides a reliable, ordered byte string, but typical apps expect messages. Makes sense. They expect messages which they will parse and make sense of according to whatever their application protocol is. Few apps use the byte stream without interpreting it. Okay, few apps use like the literally what is received by the TCP without interpreting it as some messages. Okay, then we either need to add a message layer to our TCP if we want to get messages, or add reliability and order to UDP. Okay, we will just use TCP, I guess. Former is far easier. So most apps use TCP either by using a well-known protocol on top of TCP, like something like HTTP, or by rolling their own protocol. TCP and UDP are not only functionally different, their semantics are incompatible. Okay, TCP or UDP is the first thing to decide for networked applications, and I guess here we are going to go with TCP. Although we are coding on Linux, these concepts are platform agnostic. Yes. What is a socket? That is a nice question. A socket is a handle to refer to a connection or something else. The API for networking is called the socket API, which is similar on different operating systems. The name socket has nothing to do with sockets on the wall. That is a nice clarification. A socket is a handle to refer to a connection or something else. A socket is a handle to refer to a connection or something else. The API for networking is called the socket API. So these are just handles, that is, these are just names for different things. Socket is the name for a connection or something else. The API for networking is called the socket API. API is application API. What is the full form of API? Application programming interface. Okay. Application programming interface. The application programming interface API for networking is called the socket API. And socket means a connection, which is similar on different operating systems. The name socket has nothing to do with sockets on the wall. Okay. Socket handle refers to a connection. Okay. A handle is an opaque integer, a constant integer used to refer to things that cross an API boundary. In the same way that a Twitter handle refers to a Twitter user on Linux, a handle is called a file descriptor (FD), and it's local to the process. The name file descriptor is just a name. It has nothing to do with files, or does it describe anything, nor does it describe anything. Okay, a handle is a opaque integer used to refer to things that cross an API boundary. That cross an API boundary. Okay, this I do read this part. A handle is an opaque integer used to refer to things, but that cross an API boundary. In the same way that a Twitter handle refers to a Twitter user on Linux, a handle is called a file descriptor, and it's local to the process. And it is local to the process on Linux. Okay, okay. File handle or file descriptor is local to a process in Linux, which would mean on one application, like in some process, file number one, the file descriptor one could be referring to input 1.txt, and in some other program, file descriptor one could refer to some other file. So these descriptors are local to programs, and they might refer to the same or different files. Now the socket method allocates and returns a socket file descriptor, which is used later to actually create connections, and socket is a file descriptor handle to refer to a connection. So socket returns, allocates and returns a socket file descriptor. A socket, okay. We will understand more when we are like actually writing things. While true, why are they writing this in like pseudo code? Okay, this is pseudo code. And all of this is like a bit abstract, vague and stuff. Hello. No, I am learning Rust. Yesterday I learned about like data types and how what they are. That was cool. I'm just streaming this thing. And today's stream is not very good because most of this is like just abstract things. In this whole article, they have been talking about what things are, what is, yeah, just things, theory, but no code. But in the next chapter, there will be code, and we are almost there. That would be nice. Sockets. And this is just too cool. WebSockets and all are better in Java, I guess. I I cannot argue, cannot neither deny nor confirm. I don't know. I haven't written in Java, but Java is a bad language. You should not read or do anything in Java. And it's Torvalds. What did he say? Horrible language and a horrible virtual machine. Yes, Java is a horrible language. That is what Mr. Linus Torvalds said. So do not read it, Java. Java is bad. And this sockets. Socket is a handle to refer to a connection. And a handle in Linux, the same thing, Linus Torvald, Linux is called a file descriptor. Okay, and these file descriptors are local to processes. Then we have this method, socket method, which allocates and returns a socket FT file descriptor handle, which is used later to create connections. Okay, we can move with that. A handle must be closed when you are done with to free the associated resources on the operating system side. This is the only thing in common between different types of handles. That is, we have to free them after using them. Listening socket and connection. Listening sockets and connection sockets. Okay, listening is telling the OS that an app is ready to accept TCP connections from a given port. we are like actually getting into the details. Listening is telling the OS that an app is ready to accept TCP connections from a given port. Makes sense. The OS then returns a socket handle for apps to refer to that port. The OS then returns a socket handle to the app which wants to listen on some port which refers to that port. From the listening socket, apps can receive accept incoming TCP connections, which is also represented as a socket handle. From the listening socket, using the handle, the port, the file descriptor, apps can retrieve accept incoming TCP connections, which is also represented as a socket handle. So there are two types of handles, listening handles and connection sockets. That is nice. That is very, very nice. Java was once a very good language for game development before other languages came, I guess. I'm also not sure, but there are libraries like Spring Boot. Is I've heard about Spring Boot. I guess it is a framework for building web apps in Java, like Spring Boot, which is good for these works. Yep, which works for building web applications in Java. Yo. And yes, shit. I gave yesterday a virtual contest and it was nice. The fourth question was crazy. Let's see, let's see. Yeah, the fourth question was by this guy, little sheep yawn. The fourth question was crazy. It uses dynamic programming. This one. Dynamic programming is like as to fill these. And yeah, upsolving is actually a nice thing, right? Upsolving questions after the contest. It is actually a nice thing. And yes, shit, I also want to say one more thing, which is nice. Uh, in there was contest, Division 4 contest earlier here, and in this question, this is just 1200 rated question, 1200, and this was difficult. This was difficult, and yeah, this was difficult. I was unable to do this without the editorial, and that was because there is a yes that was done. In this question we have to know a method of like two pointers method which we can use to find out how many subsegments are like correct according to us. And yeah, that was just nice. And the third question, the last contest, this one, symmetric polygons. Yes, this one just clicked. Like if you want the polygon to be symmetric, you would have to have like even number of sides, like this side has to be equal to this side has to be equal to this, and you might have bases. That is, if you have a single side which is not appearing even number of times, then you can use that as a base, and these other sides can go like this, right? And this one has to be equal to this one, and this one has to be equal to this one. Or you could have two bases, and that would be like you have two bases and then a bunch of sides which are equal to each other, like this side equal to this side equal to this side, whatever it is, and this side equal to this, and in this one and this one can be anything. Yeah, they can be anything. And we also have to make sure that the sum of all of these sides is greater than the length of this side. Only then can we use something as a base. There are some problems at low rated which are hard to solve. Yes, I think that is because we don't know the basic concepts which are required to solve them. And in the editorial, they just say, oh, now this is a classic problem, you can solve it. Like there is a question, secret number, which is hard. You also give this contest and was not able to secret number, secret number, secret number, secret number, secret number. This one, monocarp string. And there is one more problem line segment in which many high-rated problems are struggled. Line segment problems. I think this happens because we just don't have the necessary width. Like, yeah, not because these are hard, but because we just don't know the algorithms which must be used. And sockets. Yes. Check your given context in which you got lot of lines. Shit. Contests minus this one. Shit. This was division 3 and I only did one question and the rank is 19,000 is like infinite. 19,000 is a very big number. Shit. 19,000 is too big of a number. And is this the one you are referring to? Secret number. Secret number. Vadim has thought of a number x to ensure that no one can guess it. He number of zeros to the left of it and obtaining a new number y. However, as a precaution, Vadim decided to spread the number as this, find all suitable shit that Vadim could have thought of. Shit. You have a number x and you padded that number with a bunch of zeros and you called it y. So y equals x into 10 power something k and z would be the input that has been given equal x plus x into 10 power some k and k can be like k can be something I guess from 1 to 10 or something. That is how many things we can have. 10 power 9, 18, let's say 18. And this is z. And so z should be equal to x into 10 power something k plus 1. So what are the possible z's? Z, what are the possible x's? All the x's which all the z, all the values, these values for which z is divisible by this x is a possible answer. Yes. Search line segment. If you can search for question title line segment. Questions, problems, I guess. Line segments. Line segments. I don't think there is a way. No, these are just articles. Nope. Line segments doesn't seem to be there. Nope. That problem was that we have to use double data types, otherwise it fails. Double data types. Line segments. Can you like look at which contest it was? Why you do? Line segments. Line segments. Mm, we are going to manually check line segments. Incremental path. spacer, deck of cards, cut the array, discount, array reduction, quite a few things. Nope, nothing as line here. Line graph, this is this line segments. We got this, found it. Okay. Yo, yes, I was unable to do this in first try. And what is this question? You're given 2 points, this and this, on a Euclidean plane. You start at the starting point, this, and will follow n operations. In the ith operation, you must choose any point such that the Euclidean distance between your current point and that point is exactly ai, and then move to that point. Determine whether it is possible to reach the terminal point. This after performing all the operations. Hmm. Yeah. We start from a point, there is some ending point, and we can move in some line segments with some defined length. And I guess if the sum of these line segments is greater than the distance between these 2 points, then I think we should always be able to reach this point, because we can always arrange these in such a way so that we end up here. But there is only one thing that we have to keep in mind, which is that, let's say this is very big, very big, right? And we must move this much distance, and there would be a radius. Let's say we must move this much distance in the first, or at some move at some point. Then in the second move, we can move. Okay, this is our starting point, and let's say in the first move we move a very big distance, and yes, and then the sum, let's say S is the sum of all the remaining moves which are not the greatest move, right? In that case, how far can we go? There would be a radius of things we can build up to. Yep. So let's say S is the length of the places we can go up to. Okay. And then this is S, and this is the maximum length. Maximum length, if we append S directly here and directly here, then this is the area that we cannot get into, and this is the area where we can go. This is the area where we can go, and this is the area where we cannot go. And if our final Q point is within this area, then okay. If here, then nope. And if outside, then nope. So the largest distance we have to move should be smaller than the sum of the segments, including the distance. It doesn't have to be equal. It doesn't have to be uh, smaller than the sum of all the remaining distances. It just has to be enough so that this is smaller radius. We cannot go in this area. We can go into this area anywhere we want, and we cannot go outside this area. So if this Q point is in this green area, then okay, and if it is not there, then nope, it is bad, then we won't be able to get there. Let's write this. Let's actually write this. Okay, this is the question. Mhm. How is the input? Two, what is, should I have two things? And this is the starting point, this is the ending point. Int n, seen n, and int sx, sy, starting x, and ending x, ending y, sx, sy, ex, ey, and then a size n for int reference x in a, c in x, and now sort a dot r end from descending and a dot begin, or shit, r begin and r end, and also long sum initially equals 0, c in x sum plus equals x. And now we need to have a radius. Let's have a double distance between these 2 points would be square root of absolute distance between a s starting x minus starting y power 2, but this is not power 2, into absolute distance between starting x minus starting y plus absolute distance between starting, shit, I messed up, ending x, ending x, and absolute between starting y minus ending y into this thing, and take the square root of the whole thing. That is the distance. Okay, and okay, so now what is the inner and the outer radius? Double, or not double, but int long, let's say inner radius would be maximum of 0 comma maximum of 0 comma the maximum element in A, which is a0 minus the sum of all the rest of the elements, which is sm minus a0. Okay, and long outer is sm, long outer is sm. And now see out depending on dist, if dist is greater than equal to inner and dist is smaller than equal to outer, depending on this, if this is true then yes, otherwise no. How does that feel? You don't need absolute. Hmm. Absolute. Shit, makes sense. Negative, negative makes sense. And that is correct. That is correct. Makes sense. We don't need absolute. Shit, I messed up. And put this thing into this thing. Remove this. Remove this. Makes sense. Okay, let's submit. This should work. Yo, let's go. I was not able to do it, so I checked the tutorial and implemented exactly in the code, but was not using double, so it failed. Yes. Okay, shit. You're not using double here, I guess. Mm, Inner and outer makes makes sense. And yes, inner and outer makes sense. Everything here makes sense. Something doesn't. I think we don't even have to solve. We can just find the maximum element and let's say int mx maximum element is max. I think max lm is a function a dot begin and a dot end. I think max lm is a function. Nope. Max you're stopping. Yes. Max lm in C++. Max element, the whole thing. Normal forward iterator. How do you use this? Max element numbers dot begin and numbers dot end. Auto it returns a iterator. Okay. Says yes due to some reason. Makes sense. Here use mx and here also we use mx. But this does not work on a test case. Maximum element. Yes. Now yes, and star like go to that thing. Wait, this is some crazy error. Integer overflow. We are getting integer overflow and now we are not. Shit. Could we have seen that and avoided that beforehand? Yes, we could have seen that and avoided that beforehand. Okay, that should not have happened. Shit, that is bad. And look at this. Look at this. Halloumi boxes. Compilation error. 5 compilation errors in Halloumi boxes. Use long long because very big. Multiplying. Very big. Look at this. Halloumi boxes. Okay. Accepted. Halloumi boxes. Compilation error. 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 Wrong on test case 1, and then finally accepted. Halloumi boxes, the first question in CP31. Hmm. Hmm. Maybe the growth has not been too much. And yeah, I was trying to do this without looking at the question, just from memory, and that is why there was so much error. This is what I wrote, and I forgot to write a semicolon somehow, and then is sorted A. This does not even work. We have to give an iterators to A dot begin and end, and this does not even look. This does not even consider the fact that there might be different test cases. Just this just works for one test case. Yeah, so yeah, it failed. And now we can move on to, I remember, check if it is sorted or not. Yep, just check if it is sorted or not, or if k is greater than equal to 2. If that is the case, then works. Yeah, Halloumi boxes is a good question. I guess in my first competitive programmers competitive programming stream, I took about an hour and I only did one question, which was Halloumi boxes in that stream. And I was like trying to figure out how to take input and do things. That was nice. The sockets. Uh-huh. Socket is a method which allocates and returns a socket file descriptor handle, which is used later to actually create connections. Actually, either create connections or listen to connections. As a handle must be closed when you are done with it, and this is how most of the sockets are handled. Makes sense. Listening sockets and connection sockets. I just want to get on to the coding part. That would be nice. Okay, how listening is telling the operating system that an app is ready to accept TCP connections from a given port. The operating system then returns socket handle for app to refer to that port. From the listening socket, apps can receive, retrieve, accept incoming TCP connections, which is also represented as a socket handle. So there are two types of handles, listening socket and connection sockets. Okay, when we have a listening socket, when the server has a listening socket, apps can retrieve, accept incoming TCP connections, which is also represented as a socket handle. Okay, so ChatGPT. We have two types of sockets, I guess. Two types of socket, listening and the connection socket, and listening sockets are used by an application to listen for incoming TCP connections, and when such a connection actually comes, then it resolves to a connection socket, and this means whenever a new connection comes to the listening socket, whenever a new connection comes to the listening socket, we get a new connection socket. Is that like how things work? How the world is? Okay, the core idea is exactly right. Okay, let's peer it and whatever. The two sockets types in TCP. Okay, I didn't know this, so this is good to know. When writing a TCP server, like in C, Go, Python, etc., we deal with two logical distinct types of sockets. Logically distinct. These are logically distinct. Listening sockets and connection sockets. Waits, listens for new connections on server created by socket. bind, listen. Oh, okay, these are the methods. Long live France, long-lived, usually exists for the entire live stream on the server. Connection socket represents an actual established TCP connection between one client and the server. Written by the except on the listening socket, short-lived, exists only while the client is connected. Okay, so this makes so much sense. This like makes so much sense. So bro, have you learned about OSI model and TCP, UDP protocol? Only the basics, like that there are 7 different layers in the OSI model, and TCP use UDP are UDP are the transport layer. TCP gives reliable connection and ordered connection. That the packets will be received by the receiver in order. And shit, you did learning from your mistakes. Iron Man learning from his mistakes. That is nice. Yeah, so TCP is for reliable connections, but UDP just sends the data. Either it is received or not received, doesn't matter. And right now, my OBS is sending UDP packets. I guess yes, it is sending UDP packets because if some packet is lost, does not matter. What matters is the current thing which is being sent, not what was lost before, right? OBS uses UDP. Yes, OBS can use UDP for custom streaming scenarios, although it is not available in the default settings. By changing the output mode to advanced and choosing custom FFmpeg. Okay, we have to do some stream on FFmpeg. Let me okay, just going away from the topic a little bit. Uh, Strudel. This is amazing. Strudel. We can just make music. Look at this. Shit, oh shit. Yes, I messed this up. I was messing this up. 5. That is just beautiful. The music, and yes, it is audible. Okay, now it should be better, and now my voice should be better. Okay, the music is stopped. The music is stopped. I learned about OSI model last semester for 5 to 6 times. We didn't had any teacher. Every time a substitute teacher used to come and teach the exact shit, like half of the semester. It's the basics. Okay, this is the OSI model. This. Showing in your wait, which is something bad is happening, I guess. This is just very beautiful. Yes. Okay, I will do a stream on Strudel also. Just going through the docs, learning how to write in music. What you just heard, we can make it. We can literally make this. Should we can even change things, noise, LPF, LPENV, add, mix, sometimes by play. Getting started. Okay, shit. This will be workshop in German. Shit. Learning about music, it is going to be amazing. It is going to be amazing. But before that, we at least we should do some work and get some projects done. Obtaining a socket. Yeah, back to sockets. Music. That music was pretty cool. One guy came in latent and did something like this. Yeah, he was doing this. He was like saying, I'm making music with JavaScript, and he won the show. That was amazing. He won the show. Latent. Listening is telling. Yeah, so yes, there are two types of sockets, listening and connection sockets. Let's walk through a concrete example. Client, okay, yeah, that is fine. Obtain a socket using this socket handle, set the listening port, okay, create the listening port, we are listening, okay. Uh, Creating a listening socket requires at least 3 API calls. API calls to the operating system, I guess. And by API calls, they mean syscalls, I suppose. Obtain a socket handle via socket. So we get a socket handle via socket. Then listen to some port using bind function, and then create the listening socket via listen. Okay, get a file descriptor using this, then bind our file descriptor to some thing, to some port, and then say we are listening. And while true, yeah, start this call is telling the operating system to listen on this socket, and this now stops the program unless some connection comes. And when a new connection comes, we will get a new file descriptor, connection file descriptor here in this variable, and we can do something with it, and then we can close the connection. And from the client side, we get a socket, and we connect the socket to some connection, do something with it, and close it. A connection socket is created from the client side with two API calls: create a socket, and then connect the socket to some external server, I guess. Then socket creates a typeless socket, the socket type listening or connection. Okay, the socket function creates a typeless socket. So we tell it here to make it a connections socket, and here using this we make the socket a listening socket. Is determined after the listen or connect. Using connect, we make it a connection socket. You was teaching GitHub to Sumairana. Yep, GitHub is determined after the listen call. The bind between socket and listen merely sets a parameter. The bind between socket and listen, bind this thing between socket and listen merely sets a parameter telling the operating system, if I ever do something with this socket, this is the place where I would like to want to do that thing. The set socket opt API can set other options, other socket parameters that will be used later. Okay, 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 and we are already at the coding part, almost. Although TCP and UDP provide different types of services, they share the same socket API, including send and receive methods. Send and receive V methods for message-based sockets. UDP, each send V corresponds to a single packet. For byte stream based, this thing appends to consumes from byte stream. Okay, okay, yeah, okay. So we have same API calls for UDP and TCP. UDP on when we call send or receive V on UDP, we get a single packet that correspond to a single packet. But when we call these same functions on TCP, we get a stream, or like we get or we send a stream, a byte stream. On Linux, send and receive V are just a variant of the more generic write and read and write system calls for both sockets. Disk files makes sense because these are just file descriptors, handles, and send and receive V are the socket versions for read and write. Different types of handles sharing the same read write API is merely a coincidence. Different types of handles sharing the same read write API is merely a coincidence. is merely a coincidence. Okay, it is unlike to have a piece of code that works for both TCP and UDP as they are semantically incompatible. Okay, it's because UDP is sending like a single packet and TCP is sending byte streams or receiving byte streams. Summary this, yeah. For a listen socket, we use bind and listen, then we accept and then we close what we accepted. Yeah, we do read, write, and listen using a read, write, and then close and connect to create a connection socket. Okay, now we can begin with real actual code. Is this TCP client, writing a TCP client wall shit. That is like too good. Okay. Before moving on, I would like to go to the washroom and I will be right back in a minute. Yo, this is just give me a second. Check out. Crow C++. Crow. Crow, a fast and easy uh, to use framework for the web. Blazingly fast, header only. It is a single header file, Crow simple app. So this is like Express in C++, like to create an a library for writing backends in C++. JSON support is there, URL parameters as well. Yeah, so our app listen on this route. Okay, that is nice. That is nice. Crow is like the Express equivalent. It can be used to write servers, WS Windows system. For that, it might be useful for Redis. For Redis, we are like building from scratch here. This thing implementing our own sockets. We are building from the socket layer. This thing is abstracting the socket layer. We are going into the socket layer. So that is going to be nice. And before moving on, I will have to go to the washroom. I'll be right back in a minute. WebSocket might be useful for Redis WebSocket. But after some point, it would be a pain to do all that. Yeah, like this is not for production level thing. This is just to increase the understanding. And yeah, if I'm like actually trying to build something which I want to deploy, I will be using something like Crow C++. Crow C++. I tried making a kind of like live server vs code extension in C. Shit. Okay. Live server in itself is like crazy enough, and you are putting it out as a VS Code extension, and that is in C. That is pretty cool. It used to read file and automatically reload the browser whenever file changed. Very soon it got very messy. Live server. No, it was for me own learnings. Yo, let's go learning things. And okay, you are building it as a VS Code extension. Shit. And it used to see whenever a file got changed and automatically update the server. I used to Technoblade. Let's go. Technoblade, the best person ever. I used to play Minecraft, but I more than playing Minecraft, I used to like watching Technoblade. It was written in C. I wanted to try it out, how it worked, and learn WebSockets. And yes, WebSockets is like, are WebSockets different from the normal sockets which they are talking about here? Like when we call the socket function like this, is this different from WebSocket, or are they the same thing? IP layer or PP from WebSockets. Stack Overflow, 12 years ago. Let's go. 12 years, 4 months ago. Yes, latest. Here we have the thing. When you send bytes from a buffer with a normal TCP socket, the send function returns the number of bytes of the buffer that were sent. What even is the question then? The difference between two sockets, and one more time. Okay, if it is a non-blocking socket or a non-blocking send, then the number of bytes sent may be less than the size of the buffer. It is a blocking, so if it is a blocking socket or blocking send, then the number of return will match the size of the buffer, but the call may block. With WebSockets, the data that is passed to the send method is always either sent as a whole message or not at all. Also, browser WebSocket implementations do not block on the send call. Okay, I don't understand this block terminology that they are using here. And okay, but there are more important differences on receiving side of things. When the receiver does RSV or read on TCP socket, there is no guarantee that the number of bytes returned corresponds to a or single send or write on the sender side. It might be the same, it may be less or zero, and it might even be more, in which case bytes from multiple send writes are received. With WebSockets, the recipient of a message is event driven. You generally register a message handler route, and the data in the event is always the entire message that the other side sent. Okay, I don't understand where the layers are in this. Yo, let's go. Let's build Minecraft in Rust. That would be nice. Note that it can be built. Not mobs, but the whole thing. Building Minecraft made simple. 70% already there. Shit. Builditab.com. Shit. How to build houses in Minecraft. Don't want that. We want to build the whole game. How to build Minecraft game. There is a video. Making a game. How to make a game in Minecraft. Minecraft is just sandbox, so yeah, we can do anything. How to play Minecraft tips for beginners. How to build in Minecraft. Yeah, I guess this is the thing. This is the video. In 48 hours, and the video is 16 minutes long. No game engine. Shit, this does look good. Yep. Bro, guys, I've made Minecraft inside Minecraft. Shit, Conway's game of life. Uh, mind, mine. in C++ or something. I don't know. Minecraft clone. Yeah, clone should be the word I should be using. Uh, how to copy structures in Minecraft with the clone command. Yes, Reddit. There is where we go. Game dev. That is nice. You'd use STL. Okay, bro explained how to build Minecraft in 4 lines, in 3 lines. Andre88. Also check out Raylib. Should Raylib. I have heard of this. Raylib. Raylib. Simple and easy to use library to enjoy video games programming. Raylib. And OpenGL. Someone was talking about OpenGL in C++. Yeah, if we want to, I guess we can do this. We can do this. And we also have music. And look at how it like slowly fades. It slowly fades away at the end when you stop the music. This is just nice. Like when I made the whole city in Attack on Titan where Eren used to live. Shit. Volsina, there were Volsina, I guess, was the innermost wall, and yeah, there were different walls. And getting back to this, TCP servers. Yes, yes, we are at the coding part now, which is nice, which is nice, which is nice. Prerequisites. Become familiar with the socket API. Socket API. Socket API. They are saying socket API. Socket. So who are we talking to? Do they just mean like the operating system? The code is incomplete and incorrect because network programming is more than calling APIs, which you will learn as you go. Incomplete and incorrect. Okay. How to flags in G++ to optimize, and we will optimize and see what is actually 0. We have to use O0, O1, O fast, OG. Okay. Hello.cpp, and let's start the LSP by default. Plugins 7 LSP config and vim.lsp.enable lang b. Yo, let's go. And n start and hello.cpp. Yes, LSP started. I think LSP is working. Yes, it is working. And main auto socket file type socket. Standard file system file type socket cliently called object socket is not a function. It is not a function. Yeah, we will like learn how what things are with this. And now we have to get familiar with Linux. Although the principles of network programming are the same, there are many platform differences between Windows and Mac OS. For beginners, it is most convenient to just use Linux. Even if you have no Linux experience, you don't need to know much about Linux to program in it. Get a Linux environment either by VirtualBox, WSL, or cloud providers, virtual private server, VPS, and learn how to edit, move, copy, delete files. You don't have to write code in Linux. Learn how to copy files into Linux or share files with a VM. We have Mac, so that works. Compile code with G++. You don't have to mess with build systems like make files. We can simple use G++ and okay, this thing, W all. This means warning all, suppress all warnings, and warning extra, give extra warnings, and optimize globally. G, what is for G? G is for give debug information for this and this, compile these two and output the thing as program. Okay, basic programming skills. Vim, we need Vim. Basic programming skills. C programming concepts, array, struct, memory pointers. Okay, we do know about arrays, we do know about structs, we do know about memory, we do know about pointers, so that is nice. Debugging skills. Printf debugging, yes, and assert statements, and inspect syscalls with strace. Okay, what is strace? GDB. We could be using GDB. GDB. Shit. GDB docs. Documentation. Yep. User manual, single page, or we even have a PDF. 900 pages. Yes, of course. Read 900 pages for working with GDB, debugging with GDB. Shit, we don't have to go through the whole thing. We can get in and out of GDB. This chapter, getting in and out of GDB, is like 10 pages long, 12 pages long. That is crazy. And then GDB commands, running programs under GDB, stopping and continuing. Why is this so long? Running programs backwards is crazy. We can go back in programs. That is like actually crazy. Reverse step. This is amazing. This is cool. GDB is amazing. Shit. And we also have a single page version for this. Here, single page. This is not very long. Got this. One evening is all this would take. Shit. This is a lot. We're not even halfway through. We're just here. GDB, yes. Okay, and what is S trace? Stanley Kubrick, yes, of course, one of the best human beings ever. And man as trace, S trace Linux. What is S trace? S trace is a diagnostic, debugging, and instructional user space utility for Linux. It is used to monitor and tamper with interactions between processes and Linux kernel, specifically tracing system calls, signal deliveries, and changes. Okay, so I guess we can download it. Strace, download. An unsatisfied requirement. Linux is required for this software. Okay, yes, we cannot download just Linux and keep working. Tells all the syscalls. Application make strace tells the syscalls. We can just see what the syscalls are using strace. Okay, syscall trace, I guess. System calls application makes like this one. Just read the man page for it. This doesn't come. I have to be using Linux for this. Uh, so what is the S trace for Mac OS? Dtrus. Okay. Or TLDR Dtrus. Okay, it is working. Dtrus. Peach does not exist yet. Okay. Or start new vim. Man D trust, and we are at the man page. Dtrace process system called detail uses dtrace description. Dtrace prints details on process calls. It is like a dtrace version of truss and has been designed to be less intrusive than truss. Okay. Of particular interest is the elapsed time and on CPU times, which can identify both system calls that are slow to complete and those which are consuming CPU cycles. Since this uses dtrace, only users with root privileges can use this one. Hmm. Print all details. Okay, some examples of people using this thing. Okay, examples right there. dfh command. Okay, and what is dfh? Examine a specific process ID, process call, tar, d, trust, df, h, dtrust process ID, dtrust, dfh, sudo. Password and system integrity protection is on. Some features will not be available. Failed to execute df operation not permitted. Okay, I am not powerful enough to do this. System calls like standard out, standard in, etc. df is a separate Linux command. Shit, I don't like this that I cannot use strace here. Strace would be like actually nice to just see which system calls are being made, which we can see like if we do hello.cpp, and here if we do include stdio.h and printf hello world and then g++ hello.cpp or g++ optimize og. I guess it has to be capital O. Okay, og, and input is hello.cpp, output is and make assembly output is hello.s and hello.s. S is obsolete somehow. How is S obsolete? Now it is okay. Hello.s, and we have the assembly. And should we, why are we not using printf? ASCII LC0 means hello world. LC0 0. We are using puts on a loop to put this whole string onto the screen. Is actually very useful in tracing the syscalls and make the application faster by removing redundant syscalls your application is making. Should I want to use strace then? But I cannot because I unfortunately unfortunately do not have Linux. But hey, look at this thing. Okay, this thing is using puts continuously instead of calling printf once, and that does not look very good because they could just print the whole thing using one syscall. I guess it is because of the optimization. Uh-huh. Remove the optimization. Hello.cpp output hello.s. And if this thing is not optimized, we are still using puts somehow. I don't know why. And we are still using puts somehow. Compiling from source, cause even on Windows you can use with uh, MSys, and Mac too is POSIX compliant. So I guess it can be compliant. Is here brew install as trace now. An unsatisfied requirement failed this build. Yes, this was trying to build from source, but requirement was unsatisfied, and the requirement is Linux is required for this software. Yes, source code. Okay, let's do this. Okay, as trace source code. Let's build from scratch like pro programmers. This is SRACE, diagnostic, debugging, and instructional utility transport thing interface for Linux. This should work. POSIX compliant. Okay, yes, sir. Let's do this. ptrace, the operation of strace is made possible by the kernel feature. By the kernel feature, ptrace. By the kernel feature, ptrace. We need this ptrace kernel feature. Wait, is it a POSIX thing? ptrace, whatever it is. Does Mac OS have ptrace? Yes, Mac OS has ptrace, a system call. Okay. How do we build this? Uh, Distribution. Make file. There should be a make file. Makefile.am. Readme config hacking. Readme.md, which is just this thing. Yeah. Uh, Make file. Do we read in this? I don't think it would be available. Clone the repo. Okay, let's go. Let's go. Clone the repo, and then what do we do? Let's go. Tmux programming code base code bases git clone ht strace dot git, and after this first configure it with dot slash configure. Wait, from the dot slash configure in my root in my home, or do they have, they do not have a dot slash, they do not seem to have a dot slash config. Wait, where can I find the documentation for this? Like how to compile this? Please read the install git for installation instructions. Okay, my bad. Yes. 4 lines. If you use git version of strace code, there will be some files missing that are needed to be built to build strace. And some of these files are generated by tools from GNU auto conf. This thing, note, rather than auto reconfigure directly, please invoke /bootstrap script and follow the instructions given in install file for further installation. With the traditional command line interface for Linux, it is used to monitor and tamper with interactions between processes and Linux kernels. Okay, how do we build this? This is the home, git repo, nothing on building. I think I don't know what configure options are available. Wait, let me look it up real quick. If you can just like maybe let's see if there is some documentation on how to do this, because I don't know how to build things. Some of the features attached to an already running process, print paths and more info associated with file descriptors. Okay, but how do we build? We can get the latest binaries from here. Signed release tarball we can get from here. Okay, the thing is here, no targets specified. uh, make install doesn't work. I don't think a trace would work because it depends on a lot of Linux specific stuff. Yes, in homebrew also it said this here. Here is the homebrew thing. Install strace, and this depends on Linux. Linux is required for this shit. EBI is what we're missing. Shit, Mac and Unix have different kernels. Yep. ABI. ABIs would be missing. ABIs. ABIs would be missing. Why do you take so much time to read comments? Shit, my bad. My bad. ABIs would be missing. Uh, key. ABIs, like, I mean, Linux is written in C and C++, just C, not C++. So the ABI should be the same ABI throughout, right? Uh, C ABI, ABI capital, name, C ABI name. Okay. Docs for C ABI. Okay, why is ARM telling us about ABIs? Even like, look, I guess you really cannot. Shit. ABI is like API for binary files. Yes, it is the most simple and abstract answer, I guess. Yep. Just C and assembly. I mean, why isn't my comment showing? Okay, it is here. API is like application binary interface. It tells when you are calling a function and that function takes in two integers x and y, or returns one integer, for example. Then how is the function expecting those integers to be? Is it like expecting the integers to be in the first or the second register, or is the function expecting the integers to be on the stack? How are they going to talk? Are ABIs like APIs, except it works in binary? Yeah, ABIs, I would say, is more specific than that. API, yes, from my knowledge, my extreme knowledge of this thing, API is like, yes, API is like telling there is a function, some function name, and it returns some type, and it takes in some type. That is it. That is all API tells us. But an API tells us more. API is like more specific. This thing is there, right? API also tells us that there is a function. It expects, for example, let's say there is a function expecting two integers, int x and int y, and internally it will say, let's say it returns a boolean value and return, shit, I could just use this. That is too small. Fn, there is a function taking int x and int y and return x greater than y. This is semicolon. This is not I at the end, randomly I there. This is a semicolon, and this returns bool. So this thing is ABI have different functions. May have different functions. And shit, the thing about standards is that there are just a lot of them. That is the bad thing about standards. So yeah, when you have a function like this, which that is too big, and it is not going away. Okay, when you have a function which returns a certain type and does this, then in the assembly you have your registers and you have your stack, heap, everything. So when your like assembly is there, where does the assembly representation of this function expects these two arguments to be? Does it expect the arguments to be in like registers R0, R1, or does it expect these integers to be on the stack? And like even though two functions does the same thing, but if the names are different, that is different ABI. Do the same thing, not just names. Even names can be same, but let's say the C ABI, let's say I have implemented some function, this same function, let's say in C, and this same function in Rust, and eventually both of these things would be converted into assembly. This would also be converted into a as assembly. This would also be converted into assembly, and in the assembly code, where are these arguments expected and in which form? In C, maybe the arguments are expected in register 0 and in register 1, and in Rust, maybe the arguments are expected on the stack, like on the top of the stack, we would have X, and above it, we would have Y, something like this in Rust. So even though they have the same function with the same functionality with the same name, the ABIs are different. In Linux, calling conversions functions take arguments from RDI, first input. Don't know about ARM though. Okay, that is for x86, x64 Linux. In Linux, calling conventions functions take arguments from RDI, read input, R RDI first input, x86. So why is Linux telling operating systems, or why would Linux be telling languages how to take things? Even if you pass the argument, you'd need to call the function itself whose name would be different. Pass the argument, and C does not do name managing. mangling. Even if you pass the argument, you'd need to call. So C function names and assembly names would be same. In Linux conventions, function takes arguments from RDI first input. Okay, that's for x86, x64, Linux. Even if you pass the argument, you need to call the function itself. Yes, you need to call the function itself by first putting the arguments where they need to be, whose name would be different. And C does not do name mangling. So C function names and assembly function names would be same. Okay, so C translates the names of the functions directly the same as we have written them in the source code, I guess. If you create a function add2, it would still be add2 in assembly in C, C++, I think. Rust2 does not. Yeah, that is correct. That is like, yes. I mean, yeah, that is, we can literally check. We can check hello.c and let's write a function. Returns an integer and add 2. Takes an integer x and integer y. Return x plus y. And gcc hello.c output or output in assembly output hello.s hello.s and yes, the same name. The names are same. The only difference is that we have this underscore at the beginning of the name. That is the only difference. The names are literally the same thing. And let's say we change a little bit here and we compile again hello.s. Yep, the names are same. The only difference is that we have this thing at the start. And the same thing happens include std io.in. And let's say this also printf hi hello.c s shit hello.s and here we have a call to printf which is like also the same name. Yep. So suppose this suppose strace calls a function named s add2. Okay, and now in Linux the name is add2, but in Mac the name is to add, but the code would try to add to and it would crash since it cannot find. So how you expect it to run? Because strace only has my source code and it knows how names are converted from the source code in assembly in Linux, but macOS might have a different way of naming things in assembly. I guess that is the thing. Yeah, so I don't think it is gonna work out unless you create a wrapper as like my this or that on Windows does. Yeah, this is like, yeah, nope, not working. And this is cool, assembly. Unfortunately, we cannot have strace. We will have to find a like a replacement for strace, whatever that would be. And back to this thing, GDB. We might need some GDB. Okay, we can learn GDB, but strace. I don't have a strace. Miss Stack Overflow, yo. Or maybe there was a Hacker News article on 2024. Shit. Uh, yep. Yeah, the fact that macOS doesn't have ice trace is serious shortcoming. Yes. Uh, Even though I don't understand completely why, I haven't used ice trace. Exactly. And since you will be linking it to Mac, so in which would have different endpoints. Yep, they wouldn't. The translation layer would be different. Strace is a far more comprehensive tool than dtrace is a far more comprehensive tool. So dtrace is the equivalent. Dtrace. Using dtrace on Mac OS, dtrace tool, Brendan Gerg. Bro has a book on the thing. Dtrace toolkit. Okay, dtrace is something we'll have to get into. And okay, let's write some basic dtrace thing. E blog homepage. One cool feature of Windows is you can run Linux at WSL. It makes it somewhat usable. Yes, Windows is somewhat usable because we can run Linux. Why do you run Ubuntu? You run Ubuntu because you want to run Temple OS. Yo. Why do you install Firefox? You install Firefox. Shit, why do you open Internet Explorer? You open Internet Explorer to download Firefox, which is like a reference. Mr. Terry E. Davis. The problem, okay. On all current macOS versions, Catalina and my bad, wait. Yep, cool. Now much better. This isn't long. We can do this. 6 minutes read. 6 minutes stop. Let's say this was good. On all current macOS versions, Catalina 10, 15, this thing, System Integrity Protection SIP is enabled by default and prevents most users of dtrace and other tools and scripting based on dtrust. Okay, the usual way to make dtrace work on macOS is to boot into recovery mode and disable some of the shit. I cannot do this on history. Yes, TempleOS. Dtrace has a book. Yes, dtrace has a book. Did you create an OS or something? Wait, dtrace has a book. Yes, dtrace has a book. The only true operating system, TempleOS. It would be fun to run it on a virtual machine. It compiles just in time and ahead of time. Yeah, and I am a white man. I write my own compiler. Why does so simple things require to do this? Yeah, I don't know. I don't know. Why do I have to go into the recovery mode? I'm even like afraid to open the recovery mode in Mac because there is nothing to fall back to. If something goes wrong, I will have to go to the like I cannot just use a pen drive to boot something, right? I would have to go to the service center, which will ask for a lot of money. Shit. Boot into recovery mode and disable. Why do I have to do this from the recovery mode? However, this only works if you actually can boot into recovery mode. Okay, there is some hope, which isn't the case if your Mac is in a remote place and you can only access it through some sort of software, remote desktop. Okay, that is nice. We have some hope. It is also not possible, at least not via self-service to the best of my knowledge, okay, to disable SIP, System Integrity Protocol, System Integrity Protection on Mac cloud servers. Okay, so for some CI runners on services like GitHub Actions, for example, in these cases, try to change the SIP mode in the OS and not recovery fails. Okay, we do this thing. In these cases, trying to change the SIP mode in the OS and not recovery mode fails. Okay. It is better to use VM in this one. But Mac really treats its users as a child. Yep, we cannot even go to the recovery mode. Yeah, we don't know anything. It's stupid people using these crazy magic machines. Mac has nm command. What is the nm command? Yo, let's go. TLDR. We do have nm at least. What is this? List symbol names in a object file. More information here. List global external functions in a file. Path to file. List symbols. If I do hello dot, wait, what are the files I do have here? Hello, nm dot slash. Okay, yo, let's go. These are the symbols in here. With that, that is like quite a lot of symbols. Hello dot c, gcc, hello dot c, output, out, because there is no main function. There is no main function, so linker failed. Just like literally nothing. And gcc hello dot c out nm dot slash out. Okay, we have two symbols. That is nice. That is nice. Nm command, shows the functions in a binary. Write function anything and compile it to binary and use nm on that binary, and you can see the name of the functions you created. Yep, right here. Why do I have this crazy function? We can verify if nm is working or not working. Hello dot c and compile to assembly output out.s and out.s, and we have one function, this thing, but we do not have the other function which was like there, this one, mh execute header. Let's make it a little more complicated. Include std io.h and printf x plus y, and yeah, that's it. And gcc and nm, gcc row.c out dot slash out nm out. Okay, shit, we, that is nice. That is nice. I thought that this would get like cluttered and a lot of things would come. Actually, do this, write some function name, weird function name, so it does not exist in a standard lib in C and CPP both, and run this command. You will see name mangling. Oh, that makes sense. Since you didn't use the function, GCC removed it. GCC removed a function. Command use or try with CPP, a lot will come out. Like more than 500. Shit. Okay. Hello.cpp and this, and let's write my own custom function. One custom function takes an integer xy, return x plus y, and let's also use it. Wait, shit. Can we? I guess we can here. Int. We can declare the function and then use it. And shit, this code here. Yesterday, I was doing some benchmarking with my friends, seeing which language is faster, Rust or C. We ran this loop, and I told my friend to start the watch when I execute the program and stop the watch, stopwatch when this program ends. And we did the same thing with the Rust. Rust won by 900 milliseconds. Rust is faster. Thus concluded. Rust won 1 15 37, and GCC G++ hello.cpp out and nm. Okay, three things. It is optimized. It is optimized a bit. I tried doing it with my code with C. I got 58 lines and CPP gave 502 lines. Shit, loops are worst for benchmarking. Huh? Really? Shit. Name mangling. Name mangling makes so much sense. Name mangling. And if I were to compile this with Clang plus plus, then what happens? NM. Okay, at least they have the same, they seem to have the same names, name of functions, so that is nice. So this thing depends not only on the compiler, but on the operating system. So if I had Linux, this would work. This would like be the same thing, but here it is different. Wait, but if I go to assembly, out.s, and shit, the name literally changed. The name is different. Z7 cus fun II. The name is changed. Loops are worst, and Rust just uses LLVM like Clang. Yo, let's go. Chris Latner, Mr. Chris Latner, right there. Compiler design is my favorite topic. Let's go. Honestly, I can't wait to get in college. Wait, you are not even in college. That is crazy. On get in college to study that. Shit, you are not even in college. I thought you might be working job something. Shit. That is very impressive. If you know about all of these things, I didn't had any idea even how what Python is when I was in school. That is crazy. Detrus. I am currently in my drop year, preparing for JE. Yo, bro's in the matrix, preparing for JE to get the best college he can. That is something. Shit. WCL. Word count. Shit. WC is word count. Echo or char hello dot cpp word count empty. Yes, of course, empty. Hello dot cpp. Yes, it has these things, whatever these are. True enough. Yep. New got out of the matrix, and hopefully you will also get out of the matrix, so-called matrix. And shit. Okay, I will figure out how to use this. I'll figure out how to use this. Dtrace. And yes, for now, back to building our own Redis from scratch with C and C++. We need three uh, prerequisites. Debugging skills. Okay, we need these for debugging skills. But since we are pro programmers, we don't need these debugging skills. We just know what is wrong. One thing though, a lot of ideas and things as how things are solved in CS resemble a lot how it is done in maths and physics, which kind of makes sense, yes, but was still interesting, yes. GF2 instead of GDB, what is GF2? GF2 debugger, GDB front end for Linux, lightweight graphical front end. Okay, so it is not like a replacement for GDB, it is a front for GDB. And GDB uses the hood, but better GUI. We are pro programmers. We don't go after a good UI. So that looks good. Shit. This is pretty cool. What are all the variables everywhere? The assembly instructions, the assembly registers, what are the things in registers at this point, where we are in the code. Wait, this does look good. Not a GDB. Shit. This was written by Dave Roundtree. Shit, this is nice. This is nice. GF2. GF2. Use GDB under the hood. Yep, and actually makes it better to use. So, yep, it is useful and nothing bloated, at least not much. One other thing I love the most. Shit. I'm just amazed that you are in your drop year and you know all of this. That is very impressive, I would say. Hack day. Yeah. Anime picture. Just put up a anime picture in your resume, everything works out. And you must, or maybe I don't know, you might know this. Humans are also programmers. Yep. Kai lent it, literally lent it, and that is his name. And he has some amazing videos. Yeah, this channel is amazing, pretty cool. Just had a little, yep, this guy just had a little too much time. Yo, bro took the drop year to understand Linux internals. Shit, now I might actually be able to understand this after studying Rust for 2 days. Okay, 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 okay. So what are the things? Okay, we need debugging skills, for which we will need GDB. Okay, so one thing we need GDB, another thing we need strace, another thing we can use with GDB is GF2. Okay, yep. So his Rust and Emacs were the best, and his uh 10x programmer video was also pretty cool. 10x programmer video was also pretty cool. Both of them. He has two videos on a 10x programmer. They are cool. Okay, back to this thing. Back to future. C++ features are used only for optional minor conveniences like vectors and strings. You don't need to know C++, but you better need to know about dynamic arrays. Yes, we know about dynamic arrays, a character pointer, length, and the capacity. Yep. How to get documentation. Learn how to get documentation. This is not a reference book, but we will not include every detail about the socket API. Man socket point to. What is the point to thing? This command shows the man page for socket call. All API methods are syscalls. Man pages are divided into several sections as specified by the numerical suffix. Read to returns the read system call section 2 for syscall, and man this returns the read shell command in section 1, not what you want. Okay, this socket syscall and this returns the socket interface overview. These are nice things. These are nice things. The slight FP functional programming stab in Rust was pure good. Shit, I don't have the necessary prerequisite to understand this statement. The slide functional programming stab in Rust was pure bullshit. Bro, today's kids know so much in schools. Yeah, no, only I didn't know shit about programming and even computers in general. Lol. Yep, no idea about how anything is. Shit. Your man is there. Man is there in the Rust video. In like the Rust video that I did, functional programming. Shit. Rust is, I don't know, Rust is function, what even, like how you would define functional programming in specific articulated words. I guess every language would be functional language. Like we have functions, except Java. Java is like pure. Ah, shit. That makes sense. Shit, shit. I'm too stupid to understand. Yes, functional programming stab. And when he was like compiling, Rust compilation time, and at the end he just got a error. I mean, in Python we do have functions, so is it also not functional? I mean, it is not 0 1. Okay, if a language is object oriented, it cannot be functional. So Python is also functional and also object oriented. Although Python does have FP stuff. Yep, good. Yeah, that too. And that ding sound in between of his code compilation. Uh, wait, bro also knows C sharp. C sharp. Shit. That C sharp, I don't know why, seems like a alien language, which we just know that it exists somewhere outside of here, not just not here. It's kind of amalgamation of it. Python, yeah, yo, Unity, bro, game development stuff. And man, mm, there are different way how we call things here. Socket, okay. This is the thing that we are after. Man, socket 7. Shit, it did open something. Wait, that is the same thing. This is also the same thing. Okay, we can use manual pages to read things. Okay, man pages are great for looking up things you already know, but not for learning new things. There are great online resources for learning, such as Beats Guide. Yo, we have to read this book. Network programming using internet sockets. Shit, I did saw about this. Holy moly. We can get the PDF, examples, mirrors. Yo, let's go. HTML, wide screen, single page, wide screen, single page. There is just too much stuff on the internet. I gave up on C sharp after watching XML. I was learning UE 5.5, then gave up and starting on. Okay, I don't know what this is. I don't know what this is. SDL Software Development League. I went for the fun was with out earning XP. Wait, this might actually be a league. Yeah, you are in game development. I watched. I wanted to ask about shaders. No idea. How do I learn it? And what are the predefined functions in it? Sh- No, I don't have any idea, and I don't know if he might have any idea. I don't think he also knows about these things. Okay, that is so we have to learn a lot. Create a TCP server. obtain a socket handle. We can do that. Okay, sure. To revise what we have done till now in the last chapter, this was just pure theory about TCP, IP. Yes, there was serialization, deserialization, concurrency, and that sockets are of two types, listening socket and connection sockets. And they have APIs function calls, syscalls. Prerequisite, prerequisites. These are the prerequisites. In this point, everything is a prerequisite. So we need to know how to get internal documentations with something like this. And we need to know have debugging skills. We have debugging skills like programming debugging skills. I'm saying the comparison to you. Yeah. Yes, literally nothing. We don't know anything. So you wanted to make shaders for Minecraft. I have only used shaders in that. Holy shit, you did make Minecraft. That is crazy. That is crazy. And you can try one thing. It might an interesting stream. Try to make something uses STL easy or OpenGL. Yes, OpenGL would be nice, and then pass it to FMPEG frame by frame and make a kind animation. No, for Minecraft, for OpenGL in general. Okay, wait. Uh, ooh, OpenGL is for graphics, and if you okay, I don't know, but OpenGL is for graphics, like on the hardware level, almost like assembly. So when you are using OpenGL, why would you use FFmpeg? That might be a bad question, but yeah, why would you use FFmpeg if you are using OpenGL to create graphics? Or okay, I won't say one more thing yet. I have a surprise in plan. Fragments shaders and vertex shaders run on GPU. I have a lot of GPUs. Uh, number of GPUs and M1. I have a lot of GPUs. Like you cannot even fathom the strength that 7 or 8 core GPU has. Like, out of this world. That is just too much power to be held in a single machine. 8 core GPU. Uh, 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 Pinning it, piping it. Yeah, we can use FFmpeg for editing, like literally editing from the terminal itself. That would be crazy. Create a frame. Make a circle point by point and pass the frame to FFmpeg to stitch it together. Okay, so like doesn't OpenGL do it by itself because it is a graphics library and not like Photoshop where you are making things frame by frame. Okay, I will do my own research or whatever it is on this. And yeah, we can do some OpenGL stream. And I actually thought that yes, when I did the Rust stream, I thought, yes, Rust, yes, easy. We can do Rust in like 30 to 40 minutes. And after doing Rust, we will do graphics. We will see learn OpenGL. We will go here and we will learn OpenGL. But no, OpenGL for Rust. Yeah. So when I'm like really good at Rust, we can do a stream. We'll do it will take more than one stream, but yeah. And you have an animation video. So we need FFmpeg to connect. The thing OpenGL does is not video. This way you can generate video. Okay. 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 Pipelining. Rust. Rust is cool. You can learn Rust and FFmpeg Why is there FFmpeg memes? Okay, shit, this is what I searched. Uh, this guy, this guy, Fabric Bellard, and he has made a few projects. Fabrice Bellard, a French computer programmer, and look at his website. He has made FFmpeg, and this is his website. Just raw HTML without CSS and manim. Yo, let's go Python. And he has made a few projects and TinyPI, TinyEMU, QEMU for virtual machine, emulator and virtualizer, QEmax, TinyGL, and Pi for formulas, algorithms, and computation. QEMU is amazing. And where is FFmpeg? Oh, shit. Okay, right here. FFmpeg. Yeah, he has built a few projects. I started this project in year 2000 and led it for several years. Yeah. And this is his website. Bro does not have development skills, I guess. Web development skills, just raw HTML, QM. Yes, yep, that is kind of crazy. And Govin Goel. Govin Goel. Who is Govin Goel? You might ask. Govin Goel, he has some repositories. What are the repositories? Kitty. He is the guy who built Kitty. Kitty the terminal. Kitty terminal. That is amazing. He built the Kitty terminal. Yo. Competitive programming. TCC is actually pretty interesting. What is TCC? You can literally grab things and change the things. What is TCC? And shit, I'm just yapping and wasting time, mine and yours. So back to this thing, prerequisites. Okay, so before tomorrow's stream, I will like get ready the prerequisites, and tomorrow we will begin from here. Create a TCP server. How to read man pages. Okay, and yes, I'll watch. I will see how to use GDB, basic of GDBs, and something S trace, D trace, whatever it was. Sometimes right now I don't really have time to do that. Oh yo, tiny C compiler built by the same guy. Yo, crazy. Tiny C compiler, TCC, just a little thing. You need a trace, or more or less GDB can do it. You will see. Like, not just for this, it would be really cool to see syscalls being made. That would be like actually cool. And print statements, yes. Printf debugging, always, all the way. Printf and assert Mordoria. And yeah, that would be the end of today's stream. And if there is something, that would be nice. Yo, and yep, that would be the end of today's stream. And we have done quite a bit. And thank you for being here. What will you be doing tomorrow? The same thing. We will start from here. Create a TCP server, and we will keep moving forward. Shit, there's quite a lot. But yeah, we will be learning things. What are families? Unsigned integer, 16-bit, 32-bit. This is all nice. 8-bit, H, ton, L. Okay, this is heavy. This is going to be heavy. Yeah, this is going to be heavy and this will be very cool. This will be very cool. Yep, yep. I will make a repo of this. Yep. We will continue developing this, and that would be pretty cool. At least on the stream, that is what I will be doing. And it will be pretty cool to build our own Redis from scratch. Shit. GitHub, just my name, yo. Or Swagata Gintu this Gintama. And shit, YouTube is kind of hallucinating because I think more or less you are here. I'm not imagining you being here, and YouTube is saying 0. That is crazy. Okay, shit. Matrix fixed itself. Yep. And that would be it for today. Enough yapology. But this was fun. This was fun. This was fun. Yeah. And this and everything else that we did. I guess I'm just an imaginary guy. Shit. Just in my head. Yo. And that would be the end of today's stream. And thank you for being here. Bye.